Okay, homework 8, problem 1. So part A, problem 1 gives us some information that x is uniform between -2 to 2. So that means that the density function, little f of x, is uniform between -2 and 2. So I have that here. Then they say that y equals g of x, and they give us the function g of x right here. So from x equals -infinity to -1, we have g of x equals 1. So here I didn't draw it from -infinity because x only goes from -2 to 2. So we only care from -2 to 2. But if x were different, this would go from all the way from -infinity. Okay, then at x greater than or equal to -1 and less than 0, we have this function, which is 1 minus x. So at -1, plug in -1, we get 2, and this goes to 0, and it's a straight line, and at 0 we get 1, so it just goes like this. Now I draw these little circles because I wanted to show that this point is not included. This is the point that's included. And that's just from the inequality signs. Now, for x between 0 and 1, we have this new function, which is -1 plus 2x. So at 0, we get -1 right here. At 1, we get 1. So it goes like this, and the slope is of 2. And for x between 1 and infinity, we get -1. But again, I cut it off at 2 because x only exists between -2 and 2, so we don't care for x greater than 2. So this is g of x equals y. So the first part asks us to find the density function fy of y. So I find doing this is very helpful. So when we're mapping from x to y. So for the region, let's start with this region for x between 1 and 2. For x between 1 and 2, this whole region maps to a single point in y, which is -1. And if you follow the blue line here, we see that this point maps to -1. Now, whenever we have a whole region mapping to a point, that shows us it's a delta function. The only thing that matters is to find the height or the weight of this delta function. The same thing for this place. For x between -2 and -1, this maps to y equals 1. So if we follow the black line, we see here that it maps to a delta function at 1. We have to find the height, though. Now, this region, for x between -1 and 0, maps to y between 1 and 2. That's the green region here. -1 to 0 maps to this region. Region to region, we use fundamental theorem. And we have this region here, which is x between 0 and 1. And that's is mapped to the y region from -1 to 1. So we follow the red line here, 0 to 1 in x, maps to -1 to 1 in y. So for these two regions, we're going to do the fundamental theorem. But first, we know that these deltas, that there are two deltas, one at 1 and one at -1. So let's find the height or the weight of these deltas. So let's look at the delta at 1. So the probability that y equals 1 is equal to the probability that what? So it's the probability that x is in between -1 and -2, because that's where y is equal to 1. So we have -2, -1. And this is just going to become the integral of little f of x, density function, between -2 and -1. Well, between -2 and -1, little f of x is just 1/4. So we have 1/4. And then we just have -1 minus -2. These become a plus. So this becomes just 1, so we just get 1/4. Similarly, let me draw that. So at y equals 1, we have, this is 1/4, a delta whose weight is 1/4. Now we do for y equals to -1. Where does that happen? That's the probability that x is in between 1 and 2. So we have this. And that equals the integral of density function of x between 1 and 2. Between 1 and 2, we have also... Oh, I should have drawn here 1/4. That's the height of this thing. We're given that. Actually, we're not given that. Well, we are given that because we know that it's uniform, so we know it has to be 1/4. So we have f of x is 1/4, and then we evaluate, so between 2 and 1, and we just get 1/4. So this delta is also at the same height. Okay, now that we've taken care of the two deltas, we can take care of these regions. So let's first consider the region between -1 and 1, and we'll use the fundamental theorem. So we have, I'm just writing this, for the region of y between -1 and 1, we have, let's find g prime, right? So for the region between -1 and -1 and 1, right, we have, actually it should be y between -1 and 1, right? So that's the region for x between 0 and 1. So that's this function over here. So g prime of x is just 2. So we have g prime of x equals 2. We find x1. There's only one solution. That's y plus 1 to everything divided by 2. Y plus 1, everything divided by 2. So little f of y, using the fundamental theorem, is f of x, y plus 1 over 2, divided by 2. This, for y between -1 and 1, if we plug in -1, we get 0. Little f of x is 0, is 1/4. If we plug in 1, it's the same thing. It's just 1/4. So this is always going to be 1/4. So we have 1/4 divided by 2, and that equals 1/8. So for y between -1 and 1, we have here 1/8. Just constant. Now we consider the region y between 1 and 2. So that corresponds, so y between 1 and 2 corresponds to x between -1 and 0. So that's this function. G prime of this is just going to be -1. X1 is going to be minus y plus 1. Minus y plus 1. So fy of y is going to be little f of x minus y plus 1, just minus y plus 1, divided by absolute value of -1, which is just 1. This is always going to be 1/4, so we just have 1/4 divided by 1, which is just 1/4. So for here to here, we just have constant function 1/4. So this is the drawing of little f of y. So to write in summary, I'm trying to find some room here. Little f of y equals 1/4 delta function at -1. So this is for y equals -1. 1/4, we have a delta function at y of +1. Then we have just constant 1/8 for y between -1 and 1. Sorry I moved here, but I have no room. And then a constant function 1/4 for y between 1 and 2. So let me just mark that nice like this. So this is that. So that completes part A. This is the actual, let me draw this. This is the function itself. This is the drawing. So that's part A. Now, move to part B. So part B wants us to find the distribution function, capital F of y. So we can do it graphically from here, right? So at -1, it jumps to 1/4 because we have the delta. Then between -1 and 1, it's gonna be gathering area, so it's gonna be some line with slope 1/8. So, and that's gonna go from -1 to 1. So the slope of 1/8. So at y1 we have 1/8 we have, well, the area itself adds up to 1/4. So what happens is when we go from here to when we get to 1, it'll be as if we moved up by 1/4, but it's not going to move up a jump like this because it's not a delta. It's going to go like that as a line. So from this, it's going to go up by 1/4. So we know that at 1, it's going to be 1/4 plus 1/4, which is going to be 1/2. But it's going to go up as a line like this, not jump. It's going to slowly get there. But with the line is going to have slope of 1/8. So let's draw that. Right. Draw like this. And it's going to cross this axis at this point here. Now at 1 we have another delta, so it's going to jump up by another 1/4. So it goes up here. And then in between 1 and 2, by the time it reaches 2, it's going to go up by 1/4, but it's not going to jump. It's going to go slowly to 1/4. It's going to go as a line, but with a slope of 1/4. So we know that at 2, we're going to get 1, and the slope is going to be 1/4. So we go like this. And then from here on, it's just going to be 1. So that's how we do it graphically. Now when we actually write what the function is, we have to be careful. So for y less than -1, we get 0. So we can easily put that. We also know that for y greater than 2, it's just going to be 1. So for y greater than 2, or equal to 2, we just get 1. Now we got to be careful. Between -1 and 1, remember we have a line of slope 1/8, so it's going to be 1/8 y. But we got to be careful, right? We have to, because a slope of 1/8 y, this means is that it goes like this through the origin, which it doesn't. The y-intercept is somewhere over here. So we have to find what that y-intercept is. So that y-intercept is just going to be 1/4 plus 1/8, which gives us 3/8. And we can check. So at y equals 1, we plug in, we get 4/8, which is 1/2, which is exactly what we need. Plug in -1, then we get 2/8, which is just 1/4, which is exactly what we get. So that's just check. So this is the line function between -1 and 1. So this is y between -1 and 1. The same thing with this line over here for y between 1 and 2. The slope we know is going to be 1/4 y, but we have to make sure that we also find the correct y-intercept. And if we sort of extend this line here, we can see that the y-intercept is going to happen at 1/2. So let's just check. 1/4 plus 1/2. 1/2 is 2/4, so 1/4 plus 2/4 gives us 3/4, which checks out perfectly. At 2, we get 1. So we have 1/4 plus, oh, I'm sorry, 2. So we plug in 2. 2 times 1/4, 2/4, which is 1/2, plus 1/2, we get 1. So it works out. So this is the actual function, and this is the drawing. So let me just box this. Now part C asks us to find expected value of y. Okay? So we have little f of y. We got our function over here. So now we just have to apply the formula, which is the integral between negative infinity to infinity of y times f of y dy. So now we got to be careful. So we have to integrate over this entire region. So let's be careful. So let's first look for the interval between -1 and 1. So we have 2 deltas there, right? So let's take care of the deltas. So we'll have y, because we have a y here, times 1/4 delta at y equals -1 plus y divided by 4 delta y at +1. And in between, we have the constant function 1/8, and we also multiply by y, so it's y over 8. So that's part. This is not the full integral. This is just part of it. To that, we're going to add this region here between 1 and 2. And that's just going to be, you know, it's just 1/4 times y, so it's y over 4 dy between 1 and 2. Okay. So delta, when we integrate, is just going to be 1 at y equals -1 here. So we're just going to get -1/4. Here, we only get a contribution of 1 when y equals 1, so we have +1/4. This we're going to get, we have the constant out, and we have y squared over 2 between -1 and 1. These cancel. Plus this guy, which is going to be 1/4 y squared over 2 between 1 and 2. So we have this, we're just going to get 1/2 minus 1/2, because the minus cancels here. So this becomes 0. This guy becomes 1/4. We're going to get 4 over 2 minus 1/2. That's going to be 3 over 2. So we have 1/4 times 3 over 2, and this becomes 3/8. And that's the expected value of y, and that completes the problem.